Okay. Hello, my students. Good afternoon. It is 3:20 p.m. and I want to lecture over the next topic, which is on molarity. Excuse me. Okay, so this is another short and sweet calculation that is a little bit easier for you guys to do on your own and at home. So I just want to go over it fairly quickly with you guys, go over an example or two, and then I'll post the assignment just like I did before with the density assignment. Okay, so first there's a couple of definitions that I want to cover. Okay, so with molarity, the four definitions, the first one is concentration. Okay, formal definition for concentration, the amount of substance in a defined space. So if you are looking for something that is more concentrated, then the amount of substance in that space is going to be a lot higher. Okay. The next one is dilute. Okay, so if something is very dilute, it's not going to have a lot of that substance. So the formal definition, small amounts of solutes, and we're going to talk about what that word means in a moment. Small amounts of solutes in a solution. And that's opposite to the next word, which is concentrated. Something that is very concentrated in chemistry has large amounts of solutes in a solution. Okay, and then finally, the last one is your molarity, which is a unit. Okay, a unit of measurement that measures how concentrated a solution is. And the units for that are moles of your solute divided by liters of solution. Okay, so molarity is shown with a capital M. M is equal to your moles divided by your liters. Okay, excuse me. So that's it for those four basic definitions. Okay, so I just want to go over a little bit more examples with you. All right, so in your question of the day, you had something that looks similar to this. My drawings aren't as pretty as the picture that I uploaded, but you have solution A and solution B, right? Okay, so in solution A, we're going to say it's a sodium chloride or salt solution. And think of each of these little circles, each of these little dots think of it as being 1 mole, 1 particle, if you will. Okay? And think of the square that they're in. I know this one came over here looking like a rhombus or something, but the container they're in, think of it as having a volume of 1 liter. Okay? All right. So in this scenario, your solute is your sodium chloride. Okay, so the particles are your sodium chloride. That's your solutes. The solution or the liquid that you're dissolving it in is known as your solvent. Most commonly, water is your solvent. Water is considered the universal solvent. So we'll have the same thing here. So whatever you're dissolving it in, think of that as your solvent. And then the actual particles, whatever you have in that solution, is your solute. Okay? All right. So now let's do the calculation to find out which one is more concentrated. So in solution A, let's count the number of moles of NaCl that we have. This is just an example. This is not anywhere near how it happens in real life, but it kind of, I just wanted to be able to get the point across. Okay, so again, let's count the moles. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 moles of NaCl. And then I said the volume is 1 liter. Okay, so if I divide those two, I get a molarity, capital M, or a concentration is equal to 11. Right, 11 divided by 1 is just 11. So I ran out of space here, but the way this is shown in Usually like if you go into the lab or anything, this is considered an 11 molar solution. And came out wonky. Okay. All right, so let's do the same thing with the solution B. So solution B, it has 1, 2, 3, 4, 5, 6 moles of NaCl. Again, divided by 1 liter. So 6 divided by 1. So this would be considered to be a 6 molar solution. These values are very high. Typically, you won't see whole numbers like this unless you're dealing with very concentrated, or whole numbers this high, unless you're dealing with very concentrated acids. But again, this is just for an example. So solution A is an 11 molar solution. Solution B is a 6 molar solution. So I would say solution A is more concentrated because it has more solutes in the solution, and solution B is more dilute because it has fewer moles, less solute, or fewer amounts of solutes in the solution. Okay, so a way you can remember the equation for molarity, similar to what we were working with density, is by using a triangle. Okay, so in here we have our capital M for molarity is equal to your moles of solutes divided by your liters of solution. Okay, so if you guys want to remember, or you guys should remember, excuse me, that in the event that you're given your volume in milliliters, know that 1,000 mLs is equal to 1 liter. So if you're given your value in milliliters, then you would need to divide by 1,000 to convert to liters. Okay, so let's come up with our 3 equations like we did before. So my first equation that you need to know, molarity is equal to moles divided by liters, right? Okay, my second equation, if I want to look for my moles, it is equal to molarity times my volume in liters. And then my third equation, if I want to find my volume, my liters, is equal to moles divided by my molarity. Okay, so those are the 3 equations that you may be needing for the assignments. Okay, so let me just go over one example with you guys very quickly, and then that'll be it. The good thing about recording is if I talk too fast, you don't understand, that you can pause or rewind as needed, which is good. Okay, so let's see. It says, calculate the molarity of a solution. I'm not going to write down the whole thing. I'm sorry, I should have written it down beforehand. But it says, calculate the molarity of a solution if there are 1.5 moles of NaCl in 2.3 liters of solution. Okay, so this one is fairly straightforward. Okay, we're given my moles and we're given liters already. So it's asking for the calculate the molarity. So we know molarity is moles per liter. And I have both of those quantities already, so I just need to plug it in. Molarity is equal to moles per liter, which is 1.5 moles divided by 2.3 liters. Okay, so let's see. I have a calculator. So it's 1.5 divided by 2.3 equals 0.652. So I'll round that just to 2 decimal places. So it is 0.65, 0.65. So then my answer, 0.65 molar is the molarity or the concentration here. Okay, and that's pretty much it. I do want to give you a quick word of advice though. In the event that you're given grams of something, one of the things that we covered before is how to go from grams to moles, right? So say you're given, as an example, say you're given 25 grams of H2O, okay? So what you would need to do is to get the molar mass of H2O. Molar mass you get by looking at the mass from your periodic table. I don't know if I have a periodic table on here. I need to download one. If I don't think I do. No, it doesn't look like I do, I'm sorry. Okay, but you would need a periodic table, and looking at the periodic table, you would be able to get the mass of each atom and then add them together. So for example, in H2O, for H, I have 2 of them. O, I have 1 oxygen. From the periodic table, I already know hydrogen is equal to about 1 atomic mass unit. Oxygen is equal to about 16. Right, 2 times 1 is 2. And you add it together. So the mass of water is approximately 18 grams per mole. So to go from 25 grams of H2O, you would need to divide by the molar mass. So 18 grams for 1 mole. Okay, so 25 divided by 18. Let me go back to my calculator. 25 divided by 18, 1.38. So I can say 1.39, 1.4 is equal to 1.4 moles. Okay, so then now that you have the moles, you would be able to continue with your calculations using the molarity equation. Okay, but this one was just a review. This is something that, again, we covered beforehand. We've already solved how to find molar mass and all that good stuff before. So that was a quick review just in case you forgot how to do that. Okay, but again, that'll be it for this video. Okay, I'll post an assignment, and that assignment will be due on Wednesday. So you have a full day or 2 days to be working on that. If you have any questions, comments, concerns, my students, just message me through Google Classroom or leave me or send me an email, excuse me. Okay, and that's it, my students.